Good morning, everybody. I hope that you can hear me well. Welcome to this last session of this seminar of the EAAE. I am Mauro Vigani from the University of Gloucestershire in UK. I will be chairing this last session, as I say. We have three presentations. The title of this session is The Role of Non-Farm Actors. Three presentations from Professor Miranda Mewsen from the Wageningen University, one from which she just appeared on the screen. The second one from Carolina San Martin from University of Madrid, Universidad Politécnica de Madrid. And the third one from Guy Lowe from hi Guy from the Wageningen University. I want just to remind people attending that you can add your questions in the chat in the blue spot that there is on the screen, and you can write their questions from the presenters that I will then pass on to them. And I would like to remind presenters about their timing. So they have about 15 minutes for presentation plus 5 minutes for answering questions. So let's start. And with Miranda. Please, Miranda, the floor is yours.
Thank you very much then, Mauro. Nice to be in this final session with our work on the impact of COVID-19 on the farming systems in Europe through the lens of resilience thinking. Maybe someone can confirm that you clearly hear me.
I can clearly hear you.
Okay, very good then. So this is work from the SureFarm Consortium that I present. And so definitely it's teamwork. So we pretty much all hear from the 11 case study regions. And if you are interested in this publication, you can look at that agricultural system publication. It just came out. So we are studying resilience in Europe, resilience of the farming systems. And one of the key points that we acknowledge is that the resilience attributes, so system characteristics and the characteristics of the surrounding environment, that helps to build resilience of systems. And there's many of these attributes that matter. The font is probably too small for you to see all these, so I help you a bit. One of these attributes is exposure to disturbance, because once you get regularly exposed to little shocks, bigger shocks, you get used to it. You could say the dealing with risks gets in your blood, and that is helping for building resilience. And all the other attributes that you see or cannot read actually do the same, and they're all relevant. But this exposure to disturbance, I would like to zoom in on that in this presentation. Especially also, you know that resilience is not only about dealing with the risks that we already know, but also it's about dealing with the unknown unknowns. And then we had this shock of the COVID-19 lockdowns last year. And as I wrote here in red, it gave us a unique opportunity to study actually how systems can deal with an unknown unknown. It was when the lockdowns were implemented last spring, a year ago, this was unimaginable for all of us. So it was, in a way, a unique opportunity to study resilience. Because in the end, that is what you read in the middle circle, resilience is latent. It's a potential. And we already studied that in the period 2017 till 2019 by looking at very structured way to historic risks. But then we had this opportunity last year to also assess a real unknown shock that affected farming systems in Europe. So that is what I would like to talk about with you. What did we learn from that, and what did we, how can we reflect on that? Yeah, so the aim of the paper is to assess the impact of lockdowns due to COVID-19, looking to the early stage of the lockdowns. And secondly, to compare that with our pre-COVID-19 findings from the earlier assessments done in the SureFarm project. To start with the first, how did we assess this impact of the lockdowns? Well, we acted quickly when the lockdowns happened. We did structured interviews and media and policy document assessment. It's mentioned in the first bullet here. And then all the case study teams of SureFarm, so these 11 teams in the project, interpreted these findings from the interviews and the policy documents. We looked at, okay, what capacities do we see? What is the agility? So are people quickly going into the crisis mode and act? What is the degree of connectedness across actors? And who is showing leadership? And maybe to remember that when we talk about farming systems in SureFarm, that's what the figure shows at the right-hand bottom, we talk about the farming system, including farmers, but also the other actors surrounding the farmers. And just to remind you of these 11 case study regions of SureFarm, spread all over Europe, very different types of systems, and obviously also facing very different the impacts of the lockdowns. So remember, my second objective in the paper, our second objective in the paper, is to compare these lockdown findings with the pre-COVID findings. So with that 2017-19 assessments that we did. And to make that comparison, we selected results from that systematic resilience assessment. And that systematic resilience assessment in SureFarm is built up according to these 5 steps. I will not go into detail, but they will show that we always look at the farming system. We look at multiple capacities. That is what you see under this 4th figure here. So we have these structured assessments along all our assessments that we have been doing in these 11 farming systems. And that is what we compared the COVID findings with. So again, it was in a way a unique opportunity to do so. So in this comparison, we looked at 4 specific things. Well, because maybe you heard the presentations on Monday morning, we cannot compare with all the thousands of pages that we wrote about the SureFarm findings. So we selected a few that we find very important. So do we see in the COVID situation and in the pre-COVID situation, do we see similar resilience capacities or the same? What is the role of the enabling environment? Is that consistent? Does that stay the same with these shocks? Pre-existing challenges, do they persist or not? What are additional challenges, and are there system attributes that contributed to resilience during the lockdowns? So these were the 4 findings that we took out from our systematic assessment done in the pre-COVID period. There was not cherry picking, I think, but because we find these 4 points really important, important points from the systematic assessment. Well, then looking to the impact of the COVID, of the lockdowns, this early stage, not all of the systems were equally affected, especially the arable systems. Well, they were putting the seeds in the ground. It was all going fine. Some systems, however, faced heavy shocks, severe impact. That was the Spanish extensive grazing system, the sheep grazing system, due to complete stop of their sales to the local restaurants. That was also the Romanian northeast mixed small farm system, because they always sell a lot to the local wet markets. The farmers could still go there, but the consumers didn't show up anymore. So that was causing a lot of problems for these small farms in northeast Romania. You also see a circle around our Mazovia region in the east of Poland. It's a fruit and vegetable area. And they faced medium problems with regard to especially acquiring the migrant labor from Ukraine. That is on exposure and sensitivity. However, we saw in all these systems, so even in those that face little impact, we saw a lot of actions being taken. So and there was a lot of actions in terms of governments giving financial support, start of online sales, home delivery. So many actions came, and there was so much energy actually to deal with the problems. Overall, that's what I have on the upper side of the figure. Overall, you saw a lot of coping with the situation, a lot of robustness. So that capacity was very visible. Farming systems actors, so the farmers, the supply chain actors also showed capacity to be adaptive, especially in the organization of online sales, in some of the ways that migrant labor was still made available. For instance, in Spain, the government assured that the sheep shearers from Uruguay could still come over, and there was a lot of action, but mostly on robustness. Transformability, we did not see that. Of course, it was also just the first phase of the lockdown, so maybe we could also not expect really evidence for that. On the agility, leadership, and connectedness, there was a lot of agility. Actions were taken quickly where needed. Leadership, that's in the middle part. I think you don't see it exactly. Well, the leadership in some systems very much within the farming systems themselves. For instance, no, I forgot here now the good example. In some systems, though, it was the government that took action. For instance, in northeast Romania and in the Polish system, there was a lot of enabling environment actions. And in other systems, you saw both the farming system and as well as the enabling environment doing it together. The connectedness is not very visible here at the bottom, but yeah, there was a lot of variation there. In some systems, you saw a lot of connectedness among the farming system actors. For instance, I think about the Belgium dairy system, where especially processing cooperatives really worked together, cooperated to ensure that farmers could keep on delivering their milk. You see a flag on the other end of the spectrum there. That is, for instance, in the Northeast Romania system, we saw that the smallholders are not at all connected in the supply chains, and also that was the same in the crisis situation. So there was no connectedness before, and also there was no connectedness appearing during the crisis. Okay, so a lot of things happened, mainly focusing on robustness. Then the second objective of the article is the comparison with the pre-COVID-19 findings. Because if we could see persistence of findings, then that says something about predictors of resilience. Well, let's see. So these three questions that we asked ourselves was, is there this capacity in, do we see the same capacities before and during? Yeah, we can say that. There is a focus on robustness at farm level, at farming system level, and also for the enabling environment. So that was a consistent picture, broadly. Many challenges also persisted. So if we saw challenges before the crisis of access to labor, price fluctuations, then that was also very much seen during the crisis. However, there were also additional challenges. I'm thinking about the mental stress that has been mentioned a number of times, and also the total collapse of agritourism activities in Italy, for instance, and in Northeast Romania. While agritourism activities are generally seen as something good, diversifying your business, these side activities totally collapsed in this lockdown situation. So that was causing additional challenges. Third bullet here, we see that resilience attributes. I started with that, with all these, what maybe you couldn't see exactly, but I said these resilience attributes, they are important, and we indeed saw evidence that they enhance resilience. For instance, this connection, connectedness between actors was an important factor in many farming systems to find solutions in the crisis situation. Similarly, the lack of these attributes hindered find solutions. But what you see on the right bottom, we also found exceptions for all these three bullets here. So it was not exactly overlapping, and it was not exactly copying the pre-COVID analysis. Okay, so then let's go to the conclusions. Highlights. So we see that during the COVID crisis, there was a focus on immediate issues and little consideration of long-term implications. We saw that a lot before the crisis and also during the crisis. And we found confirmation of the importance of resilience attributes, as I just mentioned on the previous slide. So if there was connectedness before the crisis, this really helped during the crisis. Think about the Flanders, the Belgium example of the dairy system. That tells us that system design really matters. Being impacted by a crisis like this COVID crisis and the impacts of that is not just a matter of bad luck. I think that's a very important finding from this analysis. We also see that, in line with the previous bullet, there is so much value from these systematic resilience assessments because they pointed at vulnerabilities beforehand. They were confirmed during the crisis. So we think that these systematic type of assessments can perfectly feed into stress tests of farming systems and maybe also food systems. The fourth bullet, also very important to acknowledge, the crisis did not entirely copy the pre-COVID findings. And what to conclude about that? There's only one thing to say, I think, here. It illustrates that resilience is latent, it is dynamic, and it's quite a complex concept. Not so easy to grasp with one silver bullet, so to say. So these are four major conclusions, and we were in a way lucky to get the lockdowns, if you can say it like that. Thank you very much. I must say that last small point. I must say that when I did my PhD, it was on the assessment of classical swine fever, and exactly the same happened. When I was about to finish the PhD, people around me were saying, "Well, classical swine fever, that never happens, Miranda. What are you studying?" And believe it or not, on the 4th of February 97, that was then exactly at that time, classical swine fever happened. And yeah, this was a similar unique opportunity to use all our knowledge and findings from systematic assessment to reflect on a real crisis that was so unknown before. So we learned a lot from that, and I hope that it also gave you some interesting insight about resilience. Thank you very much on behalf of all the authors, so the Schulfarm Consortium. Thank you very much.
Thank you, Miranda. Thanks for this very interesting paper that you did as a leader of our group, and also that you very nicely presented. So we are now able to receive questions from the audience, if any. In the meantime, Miranda, I would like to ask you a thing. You said that robustness is the main type of response to this crisis, and to a lesser extent adaptability, but not transformability. I was wondering, couldn't it be because we went just really at the earlier stage, in the sense that that there might be also a kind of sequence between robustness, adaptability, and transformability, as to transform requires more time and eventually also moving investments or assets around from the farm?
Yeah, I'm very happy with that question, Mauro. Of course, we went into the early stage of the lockdowns, and you cannot change a system overnight. However, because we were a bit slow in publishing, we could also learn from the second wave of lockdowns after summer 2020, and we could see that many actors had to invent the wheel again. So in summer, everything was relaxed, and in September, we had the lockdowns again, and it was the same pattern. And we had only one example in Germany, in Altmark, not exactly in Altmark, but in another region of Germany, where slaughterhouse labor had really changed. So that was only one example where in that second wave, there was a structural change made. So
yeah, I see your point. It's really more structural than only just a sequential. But in terms of response of the government, you mentioned mainly responses from single countries. There was not a kind of, well, reaction at EU level, for example.
yeah, actually there was. The European Commission enabled food corridors, green corridors, where through which food could be imported, exported through these corridors. So that was a European-wide measure.
That's interesting. That's interesting. I don't see questions from the audience, but I think that probably we can move on, as we don't want to run late. Is that okay,
Yeah,
Miranda?
good. Yeah, good.
Many thanks for your excellent presentation. See you later.
See you later.
Bye. It's time now for a presentation from Guy Lowe. Here you are, Guy. So without further ado, please, the floor is yours with your nice paper. Go ahead.
Yep. Just confirm with me, Mauro, that you can see my screen.
Yes, but not the full screen. Yes, now it's perfect.
Fantastic. All right. So good morning, everyone. My name is Guy. I am a PhD candidate at Wageningen University and Research. Today, I will be presenting to you what is a work in progress that is my first research article, which is on reviewing the costs, benefits, and resilience impacts of mixed farming and agroforestry systems on value chains. My project is also embedded in the mixed projects. That's an EU Horizon 2020 project, which sort of follows on the heels of the Shore Farm project. So I will begin by quickly giving an outline of the presentation. So first, I will introduce a little bit the status of current food production systems around the world. Then give you a quick introduction to mixed farming, its potential, as well as its key gaps in the literature. Quickly go over the research objectives of the article, the methodology, and then some preliminary results that I can share with you. But please keep in mind that this is all work in progress and a lot of things are subject to change. So that's how it is at the moment. So the status of food production systems. Well, global food production systems can be typically characterized by their increasing intensification and rising productivity. This is thanks in part to advancements in automation and machinery, agrochemicals, plant and animal breeding programs, the globalization of supply chains for inputs and outputs. So in Europe, at least, these kinds of systems can be further typified by their intensive, large-scale and specialized nature. So in turn, all of these have led to, since the latter half of the 20th century, to what is in effect the diminishment of global hunger and malnourishment. So these are pretty good things, if you ask me. However, global food production is also equally associated with nutrient depletion and dislocation of global soils, excessive agrochemical usage, the vulnerability to extreme weather, price volatility, the erosion of rural communities, and the increasing dissonance between supply and value chain actors. And this is not as good as you can probably tell. However, there is the promise in agroecology, which itself aims to increase the sustainability and productivity of agriculture. And this is while maintaining the environment and seeking to integrate scientific elements from the disciplines of agronomy, ecology, sociology, and economics. Mixed farming systems are designed to capture synergies and complementarities between different and multiple farming enterprises, such that local resources are more effectively utilized, fostering more stable profits through diversification and better environmental and ecological stewardship. And so one very simple example is this one that is represented by these three images on the right, which is a crop and livestock or manure exchange, wherein a farming system may produce the crops that then feed the livestock, and the livestock in turn produce manure as a byproduct, which you can then fertilize the field. So it's these kinds of synergies that we like to talk about when we talk about mixed farming. So the research has generally yielded promising results for mixed farmings with respect to socioeconomic and environmental indicators, such as the stabilization of profits, improving nutrient cycling, soil fertility, and the bioregulation of pests and diseases, developing internal markets, promoting risk sharing, adaptive capacity, and buffers to deleterious externalities such as specific risks. However, we have this main issue. So this is that mixed farming is in decline in the developed world. So we can say, for example, in Europe, while specialization and intensification is increasingly becoming more significant in the developing world, such as Africa and East Asia. While the advantages and disadvantages of mixed farming at the farm level have been relatively well researched, the research has yet to explain the decline and offer insights into expanding its adoption, but in Europe, as well as maintaining these mixed farming systems in the developing world. And as an example, in Europe, so here you can see that there is a relative and absolute decline of mixed farming in comparison to specialized farm holdings between the years of 2005 and 2016. This is with Farm Accountancy Data Network data. So why can value chains be important for mixed farming research? Well, let's begin with the following statement, that value creation, capture, and transmission are key components of business, supply chain, and risk management. This is a key aspect in any and all business, economic sectors, and applies to basically any business model. And so logically, why not also in mixed farming? However, existing definitions for a mixed farming system do not account for the impact that specific systems have on value chains. Their main focus has been very much at the farm level, focusing on fusing biological, agroecological, and to an extent economic processes with spatial, temporal, and organizational integration between farming enterprises. So principally, the linkages between actors in value chains effectively determine the value of an end product, reflecting this first point on the slide. So as mixed farming is concerned with applying agroecological values to production systems, supply and value chains are implicitly going to be affected in the event that we transition from specialized to mixed, or when we look at it as the opportunity cost for remaining with mixed systems. So the key takeaway from this is that a framework for comparing and contrasting mixed farming system configurations and their value chain impacts is missing from the literature. So what about comparing and contrasting mixed farming systems? Well, mixed farming literature is disparate across different socioeconomic regions, production systems, and ecosystem processes, disciplines, and study designs. Mixed farming is also used interchangeably with only crop and livestock systems only, ignoring the other farming systems that employ similar agroecological designs and promises, such as agroforestry, crop aquaculture systems, permaculture, integrated apiculture, for instance. The comparative studies on the advantages and deficiencies of different systems and value chain configurations is lacking, particularly one with an appreciation for interdisciplinary viewpoints, socioeconomic and geographic conditions, and for the wide range of systems employed around the world. And that leads me to the research objectives of this article, which is how can mixed farming be defined and different systems compared? So this is to include value chain impacts in particular. Secondly, what mixed farming and agroforestry systems exist and what are their comparative costs, benefits, and resilience impacts? And how can the costs, benefits, and resilience impacts associated with mixed farming affect agricultural value chains? So methodology-wise, we aim to perform a semi-systematic literature review. So this is to synthesize the wide variety of literature into meta-narratives with the aim to detect themes, theoretical perspectives, and common issues in the field of mixed farming. And effectively, the objective is to summarize the state of knowledge and create an agenda for future research. And this is particularly useful when literature is disparate across many fields and when statistical measures and results are too incomparable for performing a meta-analysis. Why we do meta-narratives allow us to more qualitatively describe the different systems, given that they can be very, very different. But also this method allows us to bring together our findings from the literature and collate them with supply and value chain theory and practice. So the problem is in the literature is that there is not much value chain literature tied to mixed farming. So we aim to bring these narratives together and explain conceptually and hypothetically how these can then affect value chains in the broader perspective. So I can now share with you some preliminary results. So I have a conceptual framework that is still being worked on, but it's interesting to show you and also as a way for you to see how we are approaching our problem. So here I give you a basic definition. So in MIFAS, and maybe it's also good to elaborate what a MIFAS is. MIFAS stands for Mixed Farming and Agroforestry System, and this is to differentiate from existing definitions for mixed farming, which is usually only crop and livestock. Because we also include agroforestry, we broaden the scope of the definition to encompass other potential mixed farming systems. So in MIFAS, there is interconnectedness between the primary production cycles of two or more farming and or forestry activities. Additional value-added processes can extend the MIFAS's captured value. It is a simple definition, and that's true, but we did this intentionally because we want our definition to be a kind of catch-all for any and all possible system approaches and synergies. So not to focus only on the biological synergies and interconnectedness or the economic ones, the business level synergies, but to broaden our scope and to elaborate on the extent and degree that different systems have different synergies. So I will quickly go over some of these configurations. So the first one is really the simplest, where our MIFAS system encloses, say, a single farm business where the mixed system is being performed. So for instance, this farm business can, like in the previous example, own two separate enterprises, so cropping enterprise and a livestock enterprise, and exchanges the crops with livestock and the manure.
Guy, I'm sorry to bother you, but I have to be mind of timing, so just thank you.
All right, so I will just just this slide, and then I am finished. I'll be just a second. So this is just the simplest design. Here in the second system, we also add a little bit of appreciation for any additional off-farm added value. So this can be a milk farmer that also chooses to produce cheese or yogurt to increase the value retained within his farm business. We expand on this to also allow horizontal integration between different farm businesses, wherein the mixed system can also be a connection between different farm businesses. And we also extend our application of vertical integration to enclose also cooperatives, biogas collection, etc., to also allow both horizontal and vertical integration within the system. The value chain in and outflows are simply represented by red arrows, just to show that there are potentially differences with respect to these. So we cannot go into too much detail at the moment because this is very case specific, but this is simply how we choose to view our configurations. And so with this, I conclude. So thank you very much for your attention. And of course, you can contact me here if you have any further questions or you want me to elaborate a bit more. So I am very welcome to that. So I'm very pleased to take your questions now.
Thank you, Guy. This is very interesting indeed. We have two questions at the moment from the audience. One is from Miranda, which asks, do you expect that mixed farming systems will be appreciated by value chain actors such as wholesalers?
Well, that can really depend. For instance, it may, well, because implicitly there are going to be changes with how the farms themselves accrue costs and then transmit those costs. So potentially a mixed farming system may reduce costs by being more dependent on locally or own produced inputs or through the biosystem processes, but through perhaps loss of efficiency or reduced yields, then perhaps, or perhaps the reduced quality, then maybe wholesalers or upstream value chain actors may be less receptive to that. And that is also one of our hypotheses going into this research, which is to say that maybe the fact that there is a reduction in mixed farming systems in Europe, at least, is because there is a preference for the quick and dirty systems that are specialized.
Right.
Can be.
We have a second question, an interesting one from Peter Midmore. He asks, mixed farming appears to substitute environmental and sustainability value for short-run economic surplus. does that mean that there's sampling frame bias in the FADN dataset to the extent that mixed farming systems are rendered invisible? So in other words, how much mixed farming is covered in FADN, and is this enough to have meaningful results?
That's certainly a consideration that we are taking with us going forwards. The FADN does account for mixed farming systems within the TF14 typology set, but they do not make necessarily a distinction between different mixed farming systems. That they're not explicit with that, nor do they make any indication whatsoever of interaction, say, between farms. So the extent to which we can use the FADN is a little bit, we need to be a bit cautious and appreciate that we do have limitations with the data that we have, at least in Europe. But certainly this is an issue that we're moving forwards with.
Yes, this is indeed very important, and I guess that this affects especially agroforestry. I'm not sure that you can capture agroforestry within FADN specifically.
Yeah, we would need to extrapolate from the FADN data, perhaps for ourselves to then specify maybe if there are different systems within the FADN data set. So yeah, we need to establish a methodology for that as well. That's true.
Thanks a lot, Guy. This was very interesting. And
Thank you very much.
yes, we can now move to the third presentation. I would like just to remind the audience and everybody, and you guys as well, that we were about 66 people attending the presentation of Guy. Now, Carolina, it's your time. Please, the floor is yours.
Good morning, everybody. Thanks, Mauro. It's okay. Can you see the presentation, I hope?
Yes, it's perfect.
Okay. Thank you very much. Well, my name is Carolina San Martin. I'm talking on behalf of the rest of the co-authors of this work entitled System Dynamics Assessment to Strengthen Resilience and Sustainability of Farming System, a participatory approach. So I'm going to start with a short introduction related to resilience and farming system in Europe that seems to have a low level of resilience and sustainability. This leads to a greater probability of the farming system to suffer undesired and drastic changes when they face to shocks and ongoing stresses. We understand sustainability as an adequate performance and balance of functions across the three dimensions of the farming system that are the economic, the environmental, and the social dimensions. We understand resilience as the capacity of the farming systems to deal with the challenges according to the definition of the Sur Farm project, in which they propose a framework to analyze the resilience of farming system. They distinguish the three different types of resilience variables: the challenges that are referred to shocks and long-term pressures, the functions referred to the provision of private and public goods, and the resilience attribute that are those characteristics or competences which presence make the system more resilient. This framework focuses on the assessment of these variables individually. As Miranda said in her presentation, with the framework in 5 separate steps, and it only states the impact of challenges on the farming function. So we hypothesize that there are other relationships apart from the impact of challenge on function. We consider also that maybe there's an impact of challenges in resilience attribute, for example, or an impact of the resilience attribute in the function. For the analysis of those relationships, the causal loop diagrams are interesting as they are qualitative system dynamics models in which we can observe all the relationship between all the variables in the system. There are other works like the one from Herrera and Kopinski in which they analyze the resilience of the farming system, but they don't distinguish between this type of variables inside the causal loop diagram. So the objective of the study is the analysis of those relationships between challenges, function, and resilience attributes that allow with this analysis of the relationship allow us to assess the resilience and the sustainability of the farming system more deeply. And we have chosen the SIP extensive farming system in Huesca, that is a province located in the northeast of Spain. For the construction of the causal loop diagram, we took the insights of the stakeholders of the local stakeholders in a participatory workshop, the Fopia Sur Farm workshop, and in this workshop, participants were asked to identify the most important resilience variables of the farming system and to establish relationship between them. In that way, all the participants were able to build their own individual causal loop diagram, and then in the plenary session, we put all together all the ideas, and we were able to construct an unified diagram. Then, from this unified diagram, we added some inputs that we consider that were necessary to make the diagram more sensible, and we obtained a final diagram. With this, as I said, with this diagram, we were able to see the different types of relationship, not only between variables, but also between the different dimensions in the farming system. Well, here is the final causal loop diagram. We can see in it that there are 3 different dimensions that are distinguished by different color. The economic, technical, we mix the technical part. The technical part of the system in this dimension, a social dimension, and also an environmental dimension. In colors, we can also distinguish the different kind of resilience variable. In orange, we can see the challenges as the low demand of land meat, the low sector attractiveness, the increasing feeding cost, the wild fauna attacks, and the lack of available and accessible land by the livestock farmers. The participant also consider the policies and regulation as challenges, and here in the causal loop diagrams are represented by the rural development programs, the urban and sanitary legislations, the public aids, and the environmental legislation. In purple, we can see the function of the system related to the provision of meat. Sorry, the syrup of the attractiveness of the region, the assurance of the quality of life of farmers by providing good working conditions. Sorry. The provision of a reasonable livelihood for farmers, and the maintenance of the natural resources that in this case are the pasture land. So if those pasture lands are not maintained, the shrub stratum increase and the pasture land and the grass stratum disappear. We also distinguish the resilience variable in this green blue color that are related with the resilience variable provided by Reitsma and Paz and are referred to the capacity or the ability of the farm to be reasonably profitable regarding to the innovation too. Related to the technification of the system, the ability of farmers to cooperate between themselves, and the ability or the ability of the system to be coupled with the natural resources that are the pasture land. We also identify some variables here in frame that are referred to the stock, that are those variables that are that change slowly in time. So we can see that the challenges in the farming system are mostly internal. Some of them at the first it seemed that they are external, but no. For example, it's the case of the meat demand, that it's also controlled by the rural population, and there are only the policies and regulations seems to be external variables, challenges. Sorry. And when we go deeply in the diagram, we can see that some challenges are actually resilience attribute with a low performance. This is the case of the policies that they are necessary to stimulate the resilience of the sector, especially in the extensive sector. And in the case of the sector attractiveness, it represents the low capacity that at this moment has the sector to be profitable and to attract workforce to the region. Related to the relationship between variables, we can see that some of them have a direct impact on others, and we can see that not only the relationship between challenge and function exists. This is the clearest example is the effect of the meat demand on the farm profits. But we can see also other impacts as the challenges, the impact that challenges have on resilience attribute. For example, the lack of availability of lands have an effect on the grazing, or the effect of the resilience attribute on function. For example, the better is the degree of technification, the better are the farm profits, or the effect of the resilience attribute on challenges. For example, the grazing. The better the grazing, the lower are the feed costs, because farmers don't need to feed animals with external inputs, because they have these natural resources that are the pasture lands. And there are other relationships. I don't have too much time to analyze all of them. We can see also that not only the impact of one variable is direct on another variable, they only and indirectly impact in others, because they take part of these feedback loops that are close relationship between variables, and that makes that the changes or the impacts on this function, for example, the farm profits, are going to have, for example, an impact on the animal handling, and we can see that the feedback loops in the economic and environmental dimension are shorter than in the social dimension. And in the social dimension, there are more intermediate variables, and there are more variables that are stocks. So that leads us to understand that social or the impact of social variables into other social variables are slower or they have blurry effects on others. This is the example of the sector attractiveness, for example, on the farm profits. The farm profits, of course, they have a direct impact on the sector attractiveness, but the effect of the sector attractiveness in the farm profit has to pass through a lot of variables that sometimes they are stuck and they evolve slowly in time. So that's a good point. Well, we can see regarding the dimensions that all the three dimensions in the farming system are connected, not only through the farm profits, because they are impacted by the meat demand or the degree of technification or the feed costs that are influenced by the grazing, but there are other variables that connect the dimensions. For example, the number of farms are affected by the number of successors or entrants, or the land availability, or the degree technification impact not only on the farm profits, but also in the grazing and the quality of life through the animal handling. And the farm cooperation also having an impact in the quality of life and the environmental dimension because of the possible crop farming agreements to use the lands in the region. So it's important to remark that the actions not only have to be addressed to the farm profits, but also on other variables that are important to the functioning of the system, and that of course they are going to have an impact on the farm profits. And
hi, Carolina. Sorry, can you please?
Yeah, this is there's another slide.
Oh, sorry. Great.
Don't worry. Okay. And there are some other variables as the availability of land, the sector and region attractiveness, the sector knowledge, the technification of the sector, and of course the policies and regulations that need to be focused on when we plan the strategies and measures on the sector. And for finishing, these are the main messages of this work. The causal loop diagram reveals that challenges affect not only the farming system function, but might also turn weaker the resilience attribute that in turn affect the provision of function provided. The strategies for the future need to be diverse enough to deal with challenges, but also to deal with weak resilience attributes. Economic, social, and environmental dimensions in the farming system are interconnected, indicating that a combination of actions regarding each dimension need to be performed to turn the system resilient and sustainable. The actions should not only improve farm profits, but also other aspects as the attractiveness of the rural areas and the access to lands. So thank you for your attention.
Thank you, Carolina. This was very interesting. Many thanks, and very complex. We have time for probably one question, and then we have to move on to the next and final plenary session of the seminar. So we have a question from Miranda. So the causal loop diagrams illustrate the complexity of resilience. Did you find key variables? So for example, top 3 variables that can illustrate this complexity?
I think Miranda means about concrete variables in the extensive seed farming system.
Yes, that illustrate the complexity of resilience.
Okay, I think the most important variables in this case is to improve the sector and the region attractiveness of the sector. That will improve the social dimension of the farming system. Also, the availability of lands and the access to land to improve this environmental dimension, and of course the farm profits of the sector, because as we saw, it's there are a lot of arrows that goes to the farm profits. So if farm profits fail, there are some other variables that are going to fail.
Right. We have a second question also from Eric Mattes about the length of feedback loops and blurriness of effects. Is this not also a result of how you define variables? For example, are all variables defined at the same level of abstraction or concreteness?
Yeah, well, we have to have in mind that this causal loop was constructed by the perception of stakeholders. So it's true that sometimes maybe there's no this all the variables have not the same importance in the causal loop diagram. But what we wanted to see with this diagram were only the relationship. We haven't analyzed the importance of each variable. So maybe, yeah, I understand the question of Eric, but we didn't see the different importance of the variables. So
right. Okay, fair enough. So I'm afraid that we have to close here this session. We already stole 5 or 6 minutes to the next one. Thanks a lot, Carolina.
thank you.
Thanks
Mauro.
a lot, Guy. Thanks a lot, Miranda. I hope everybody was interested. And well, see you in a moment in the next session.